Hello everybody, we're getting ready to do lesson 3.2 for Algebra 2 Math. And if you need other lessons, other PowerPoints, because I'm doing part 1s here, contact me here and I can get those for you. This is part 1, 3.2, Applied Properties of Rational Exponents. We got a 30-point skill check at the end of this PowerPoint here. If you want that, email me. And we have 4 points of note-taking. Teachers, this is your student spell work here. Solve the equation. Give them about 5 minutes to solve these. And attach a sheet, students. If you need more room, attach a sheet. Okay, welcome back. The solutions for our bell work. Here is the first solution here. You come up with the cube root of -15. And then here, x minus 6, we go through, we take the 6th root of 215, and that's our solution here. Okay, so applying properties of rational exponents, you simplify expression using integer exponents. You'll simplify expression using rational exponents. So, key concept here, properties of rational exponents. Let a and b be real numbers, and let m and n be rational numbers. The following properties have the same names as those listed, but now apply to rational exponents as illustrated. So here is the product of property here. And then here is an example of that using fractionated exponents here. So we're using fractionated now instead of integers. Then here's a power property here, again using fractionated exponents here. And then here's a power property. And using fractionated exponents here on this quantity here, this is what we come up with. And we get 4 times 3 equals 12. The square root of 4 times square root of 9. 1/2 is a radical. Okay, now properties of rational exponents. Let a and b be real numbers. We continue here. A to the negative m. This is the quotient property of exponents. And then here is again another example. Oh, this is a negative property here. This is a reciprocation of exponents, and then this would be the quotient property here, a to the m minus n. We have an example here of that using, again, fractionated exponents. And then here is the power property of exponents. Power of a power, actually, these are a to 1, a to b to the -1. So here is an example here, and then we come up with this solution using these examples here. Use properties of exponents. So we have rational exponents here. So this is an example here of a product of powers property where we have the same base and we add our exponents here and they're fractionated. And then this one here, use a power of a power property here. So we multiply through, we multiply by 2 into our exponents here. And we come up with this here, 6 to the first power times 4 to the 2/3 power. And then 4 to the 5th, again, it'd be another power of a power property here. Multiply through by -1/5, and we come up with 1/12 here after doing our multiplications here. We come up with 12 to the -1 power. Okay, so use properties of exponents, use properties of rational exponents to simplify this expression here. 5/5 to the 1/3 power. And we use our quotient property of exponents to get this 5 2/3 power here. Then power of a power property here, multiply these by 2, and we end up with 7 and 2/3 power. Okay, here's our guided practice. Students, here's yours. Simplify this expression. Do this one up here in our guided practice. We have a power of a power situation here, and multiply through by 3 into our 20 over 5 to the 1/2 power. And we get 4 and 1/2, 4 to the 1/2 power cubed, which is 4 to the 3 over 2 power, which would be 2 to the 3rd power, which would be 8. Apply properties of exponents. A mammal's surface area can be approximated by this model here, where m is the mass in grams of the mammal and k is a constant. The values of k for some mammals are shown below. Approximate the surface area of a rabbit that has a mass of 3.4 kilograms, and they give it to that in scientific notation here. So here's our model. Here's our plug-in here. We need to have k here, which is 9.75, and then our 3.4 times 10 to the 3rd grams. Substitute 9.75 for k, and then 3.4 times 10 to the 3rd for m. Power of a product property here is what we use. Power of a product, or product of a power. And then we 3.4 to the 2/3 power is 2.26, and then this turns out to be 10 squared. We have our product there that we come up. We have approximately 2200, so it's about 2200 square centimeters for the surface area of that. And now we're going to come up with a guided practice here. And students, this is your problem here. Basically, it's the same problem, but we have a bat and we have a human. So I got a practice here of a sheep. So here's our original formula for that. And then we plug in here our values from a sheep going back to the table. This is our values here. And for this 9.5, this is your plug-in for 95 kilograms is there to the 2/3 power. So again, we separate this product off by the power here, power of a product. And then we come up with this number here, then we do our calculations, probably on a calculator, and we come up with this number here. Sheep surface area about 17,506 square centimeters. Okay. If you want the note-taking guide and the worksheets, email me here. If you want part 2 and part 3 of this lesson, email me here for PowerPoints and video. And thank you very much.